accepted.
Okay, who's still here from the last one? Oh, you are so bored, aren't you? Yeah. Okay, 3 things that each developer should know. So let's see. Go to Devoxx Poland. What do you do for another thing?
The other thing was like the coffee, right? That you have to drink in
Oh
order
yeah,
to
drink
write.
coffee
Yeah.
and smoke cigars.
Yeah.
Yep, that's the one.
Three.
First professional developer I ever met, big guy, really big guy, and he had a pot of black coffee. He brought his own coffee machine, and he had a pot of black coffee, and he sat there and basically drank it and smoked cigars. And I was like, that's what developers do. But luckily I learned otherwise. Okay, go on then, thank you. So for those of you who weren't on the previous one, that's me. My name is Steve Poole. I work for a company called Cernotype. I'm the Director of Developer Advocacy for my pains.
And I'm Olimpiu. I'm working for a company from Romania that is doing custom software product management, development, and we try to transform for those guys that don't have any kind of assistance in terms of software into magic.
Yeah. So Cernotype are the company that provide Maven Central, which I know you know because you'll be using it, but also we do these other things like Nexus and Lifecycle, which you may be using commercially. And we have a little thing called Bomb Doctor, which if you're interested in the story, we won't show you a demo, but it's worth playing around with. Okay, so, hey, I'm going to do what I just did. So those of you who were here before can go to sleep for a bit. So we want to talk about good stuff. So what are the 3 things? So the 3 things we want to talk about are actually related to this. And defenses. So we want to talk about cyber attacks, we want to talk about S-bombs, supply chains, and you. So we'll start here. I feel like I'm just repeating myself, but for those of you who weren't here, 2016, not that long ago, the drug trade, the thing which is all very physical, where we see people in all those wonderful movies who are taking drugs and, producing them, selling them, and buying fast cars and getting shot and all that stuff. The drug trade was worth $450 billion. And about the same time, the cybercrime thing just about peaked it, about 453. Okay? And then $450 billion was equivalent to about buying 50 of these Nimitz aircraft carriers. And if you've ever seen pictures of them, they're pretty big. And 50 is about, I think the number is there's probably less than 50 aircraft carriers in the world. So you could buy 50 for the money that the world paid, either by giving it to the bad guys or by the consequences of the damage that cybercrime caused, $450 billion. And now, 2023, what does it look like? Just had a gentleman going, $11.5 trillion. That doesn't sound possible, but believe me, it is. But this is what we're talking about. So $11.5 trillion is how much cybercrime is costing us. Now that comes from a mix of the bad guys getting money through like ransomware, and through the damage they cause, through insurance companies paying off, it's all sums. It's enormous amounts of money, and the reason it's an enormous amount of money is because it's easy to do, and there's no simple way of stopping them. And if you took that number and turned it into GDP, cybercrime would be the 3rd largest country in the world. Get that? It's like Atlantis just popped up and said, hey, we're the 3rd largest country in the world, and we have $11 trillion coming through our hands. That's how big the problem is. So we want to talk about the consequence of this and what you need to know, the very simplest stuff to help you understand this. As you can see, the number doesn't seem to slow down, right? It's just going to go. And that is because we don't have the defenses. Something we want to talk about. And laughing funny though this is, it's really true. If cybercrime, if Escobar was around now, he'd be doing this, he wouldn't be doing drugs, because drugs is physical, you get caught for that, you get shot for it. All sorts of horrible things happen to you and your customers, whereas cybercrime is just easy, there are no consequences, hardly anybody ever gets caught for doing this. How do you prosecute somebody the other side of the world for attacking your system? You don't. So it's a pretty easy life. But it's scary, isn't it? And then it gets even more scary, because that's just for money. There's this new thing. People have realized that all the technologies that you can use to attack people for money can be used for other purposes. So actually, we're now talking about cyber warfare. We're talking about economic warfare. So all these technologies that were used with big heavy sticks to get money out of you are now being used to get into your systems with the idea of compromising them. Originally, the idea was to get into your systems so that you could compromise them in the case of a war. You imagine you get into somebody's systems and you go, in the event of a war with this country, we can turn off their electricity systems so they can't produce stuff. But suddenly people began to realize that, well, why don't we just do it now and then again anyway? Why don't we just low-grade attack other countries? Because it affects their economy. And that's what we're talking about. They're getting into your power systems. They want to get into your chemical supply systems. They want to get into your supermarkets, your delivery systems. Because at some point, they're going to want to get in there and affect it. It might be catastrophic. It might be invisible. It might be as simple as switching shipping labels so that goods get sent to the wrong person, causes confusion, costs you money. This is what's happening, and this is going to be our life from now on. And if you want to hear the latest, do you want to talk about the latest?
I will try to bring it a little bit closer to our region. I'm from Romania, so I know that you heard about these things. At least in our side of the country, you start hearing more and more Ukrainian in the last 1 year and a half, and these are the facts that happen. A couple of billion new people are just displaced internally or moving around Europe or the world. A couple of thousands are dead, others are injured, and almost more than a half of a billion trillion dollars is to be used to rebuild the country. But what does this have to do with the cybercrime? Looking at the graphics, how the things are looked before the war in Ukraine started, this is the activity on GameRedon servers, and they just went a couple of scales up, just before the country was invaded. Before bringing tanks, bringing airplanes, everything happened that in the cyberspace. As Steve was mentioning, they tried attacking it. And of course, those things don't remain only in Ukraine. They went outside the borders of Ukraine. Even Germany, a couple of the power mills in Germany were shut down because the Starlink connection that they used was the one that the Ukrainian government was using. And what are the new weapons? What are the new weapons of electronic destruction these days? Well, they are wipers, they are different type of malware, they are distributed denial of service types of attacks, industrial, and they just don't stop there. So now the black market has a lot of those tools available, and they are used against us, against you, against everybody around ourselves. But the last year, not only bad things happened. Also, AI appeared on the horizon. So now we have our Siri that really knows how to do proper things. We have our virtual assistant that helps us. But guess what? There are these guys across the border, across the chasm, that want to use it as well, and they use it. And they use it against us again. They just augment their capabilities, and they build better or worse in this condition tools that are against us. And even if we don't think about it, there is a new attack vector, prompt injection, and all the other nasty stuff that can be used against us. But maybe Steve has more to tell us about it.
Yeah, so prompt kiddies. Who's used ChatGPT or similar? Awesome, isn't it? Apart from when it does wrong things. It's a really wonderful tool if you're not particularly good at writing code, but you want to make some money. And now we have these things called prompt kiddies. This is a real thing. We used to have script kiddies, we still have script kiddies, who basically bash something out and try and get into your systems through the easiest manner. Well, now we've got prompt kiddies. And they're using ChatGPT and similar to craft actually very sophisticated attacks. This one is one that ended up in PyPy, I think it was, right? But when you've got a tool that you can say, generate me some code that does this, and mostly it works, great. And then you can use ChatGPT to create very specific attacks on you individually, because it's quite possible to craft emails to you from your boss that you may not be able to spot. So this stuff is, going to be yet another big weapon in their arsenal. So what are they doing with this stuff? Well, everything's ratcheting up. So it used to be the bad guys would just wait for these vulnerabilities to be discovered. There'd be a problem in somewhere, somebody would find it, get published, and the bad guys go, thank you very much, I'm going to see if I can exploit it. But that's not what they do anymore. We're in this model. They make their own. And some of this stuff is automated. So dependency confusion is, in some repo systems, it's possible for me to publish, say, foo at version 1, Olimpiu to publish foo at version 2. Okay? Even though I own it, he can still publish the same thing. And when you have systems where maybe your build system is used to go and pull down latest, it may not pull down the latest from me because he's put a version, published one that's a high version, like 999. Those sorts of things, right? Typo squatting. The number of times that you've typed in maybe you've had a dependency in your POM and you just spelt it wrong, and of course it's can't find it because I misspelled 2 letters. Typo. Well, guess what? The bad guys are good at figuring out what those typos are and creating payloads that match. So the next time you do a typo, rather than you're being told it doesn't exist, actually does exist, and it's got bad stuff in it. Right? And that stuff is happening, that's automated. Bots out there doing that all the time. Right? And then, of course, the usual sort of social engineering stuff. And the big thing, the easiest thing for everybody, from a bad guy point of view, is to build systems, is to get into your build systems. Because your build systems, the build systems of the open source projects you're consuming, because the build systems tend not to be secured. And all you have to do is get into that last bit where you create the zip before you publish it. Thank you very much. And that's what they're trying to do. The good news is some of these attacks are not valid in Java, or they're really hard to do in Java, but you get the idea. There's a whole bunch of people out there trying to do that. And the time that you have to deal with this when you find out has gone from being 45 days, 2006, such a long time ago. 45 days you had from somebody telling you that there's a problem to you fixing it. Log4j, the thing we love, 2021, showed us that that window had closed because Log4j had actually been out in the wild for years. And suddenly it was being exploited, right? What you have to understand is this is now another weapon, and people will try, nation states will try and prevent the publication of these vulnerabilities because they are weapons, as I said. We have, strong evidence of people being paid large amounts of money to do this. And other countries, China for instance, are going, you can't report this anymore, you have to go via the government, because for the same reasons. Can I make use of this as a weapon? Right. So it turns out that the more severe these vulnerabilities are as they're discovered, they're more likely not to get reported. So we're in a new world, and this new world is exploit first. Right? And believe me, there's a whole bunch of people out there who are now going, this can make me money if I can find a vulnerability. Whether I can make it, whether I can discover it, it's worth millions of dollars. So we're now in this world. Exploit first. So the first thing that you need to know out of all the three is this. Modern cyber attacks are about supply chains. They're about getting into the dependencies that you use. They're getting into the build systems you use. They're getting into the build systems of the dependencies you use, all that. And they're never going to go away because they have become a weapon. And everybody wants to manage it and constrain it. All the governments want to do that, but it's still a thing. And it's never going to go away. And we're all part of a supply chain, not a software supply chain. We're all part of a business supply chain. One way or the other, we're all targets.
Yeah, but that's something in the news, right?
Yeah.
We don't care about it. We write perfect code. We don't care about those things. They are sci-fi. And we definitely don't introduce bugs. I never met any programmer personally that introduced bugs. But how about the other part of the software that you drag in your systems that you build, the 90% that are part of the supply chain, the part that is written through open source tools that we take, we reference in our software, we don't know about those guys. We don't know what they are doing. And those guys are facilitating countries like North Korea to build a nuclear arsenal and transform the open source that currently is electronic weapon into real weapons of mass destruction that sometimes might be used. So let's see what we can do in this perspective. What can each of us do? Because in the end, we are all parts of this ecosystem, and we are able to do something about it. So let's dive into what it means to secure our software supply chain. How many of you are already doing that? Can we see a couple of hands up? Okay, happy to see a couple of you that are trying to do it. But for those of us that we don't, there are a couple of other guys that try to look into this. And obviously, US is the first one to ring the bell. And they started a couple of years back, I think 3 years ago, when they came out with the first coder of US came back and said, okay, we need to look into these aspects on how we can secure the supply chain. And then zooming in, they realized that, as we already know, software is eating the world. And now they encourage us, for now, but it will come the moment when they enforce it on us, to make sure that we are responsible for what we are putting out. And of course, exactly after it, like normally, European Union followed suit. And after that, even if UK doesn't agree with the European Union, it agrees on the fact that cybersecurity is a fact, and also the legislation is being changed.
Yeah.
And it's happening around the world.
And the list goes on.
Yeah. Japan, Australia, all over the place.
Yeah.
It's already happening. And if you don't like governments, well, I know for sure that I don't, there are other organizations that are both open source or committees or NGOs that are looking into this space in order to make sure that we do something about putting a lid on everything that is spilling out currently. And You probably know about OWASP, you know about OpenSSL, that is a program of the Linux Foundation. Cloud Native Foundation is also involved, and all the other government organizations. And they want us to know one thing. And that thing is that we need to harden our software supply chain. We need to harden the way how we build software. And we can do a bunch of things. We'll not talk about all of them, but what I can tell you for sure is that the important aspect, and that comes the intersection point at this particular point of time, it's the software bill of material, or SBOM. What does that bring? Yeah, let's see what are the standards that we are asked to use. By the decree of the US that started this story, currently there are 3 formats. The upper ones are the most important ones in terms of usage and usage on the market, and that's SPDX that is brought by the Linux Foundation. The other one is CycloneDX that is done by OWASP. The one in the lower part is usually used for legal matters, and it's here for a couple of years now. But what all these formats have in common is the fact that they are machine readable, they are open source or open format, they are interchangeable, so regardless of what format you use, somebody else can take it, transform it into its own, and then use it. And last but not least, it provides everything underneath it. It provides, in plain words, transparency. And this is just the beginning.
So anybody here heard of an SBOM? Okay. Wow. Good. Well, you're going to learn about SBOMs. Yeah.
So now we can add this to your vocabulary, hopefully, and that's what a SBOM actually is. The software bill of material, it's by no means a silver bullet for the security, but it's a good place to start. It's a good place to start building that foundation that we actually need. And it does an X-ray. It does a manifest file, name it as you want, a label that you can see on the food or you can see on the medication, with everything that is under the hood of your software. As a plain example, you can look at Slack that lately started using that, and it just lists all the libraries with versions and everything else that is used there. So you can just see it and just check for yourself if it's vulnerable or not. You can do that with your own. But why do we need to do it? The tools that we currently use are as good as they can, or as good as they get. And we need to think about more. Our software development platforms are getting more and more complex. It's not enough to look only at the code level. It's not enough to look only in jar files, in zip files, in any kind of archive. It's not enough to look at the file system, because we currently have Docker images, we have Kubernetes, we have ISO files, we have RPMs, you name it. We have a big tutti frutti there that we just brought together. And our software tools need to be able to look into that, need to look recursively, look at transient dependencies, look at class files, look at archives of different formats, and even at the place where you can not imagine to have classes, hidden files, and all this other stuff that we actually never thought about. Things that are in terms of attack.
So what we're talking about here is finding code that may have vulnerabilities in. And what the bad guys are also trying to do is hide it. So it isn't just finding code that you may have put there, they're also trying to hide things as well. So, the scanning tools, the big challenge of the scanning tools is you don't know whether you have a good one or not. Because if it's not a very good one, it won't find things, and you won't know.
Yeah. Actually, in a talk that we gave last week, we had the comparison, and one tool that we used came out with 4 vulnerabilities, the other one came out with 76. So it's a matter of having the right tool for the bad job, right? Because that's the worst thing that we can see. And the main purpose now is, with the software bill of material, is that we don't want to use the microscope to look into the cake that we just baked, to understand what are the ingredients that we had. It's about time to look at the label, understand it before using the recipe, and that's about it, to really know what we're getting into when we pick a library or another. And because the pipeline is the one that actually provides the backbone of our software development, let's complicate it.
I've got to take a photo. Carry on.
Yeah, okay, great. I can share the picture if you want. So it's the way how a software vulnerability scanner should work. On that side, on the right-hand side, the left-hand side, in your case, sorry, we are European and UK, so we mix sides. It's about the repositories that we currently have, and its source code. There are Docker files. There are registry in that regard, and from that point on, we can have software bill of materials. Software bill of materials that are zooming in and telling us in a couple of hundreds, thousands of lines what is actually there. And after that, a vulnerability scanner can come and check each and every one of those dependencies and make sure that they are scanned against databases of vulnerabilities. Some of them are from Sonatype, that they are aggregating a lot of this information. They are the ones from the US National Institute about that. Red Hat has it, Oracle, Debian, pretty much everybody that is into delivering software and it counts has something and it's aggregating it. And the other point that we want to find out is what are the issues that we currently have under the hood? What are the pandemics, the viruses that are lurking in our systems? And after that, obviously, we want to patch it. We want to be able to do it fast, to do it properly, to make sure that not everything is lost in our work. And the new kids on the block that appeared, more than S-bombs, the other two that are creating this triplet of making things more secure, it's Sigstore. That means signing and making sure that whoever says that build that, and it's certified that that's actually happening. And the other one is reproducible builds. That is for those of us that really want to do it ourselves, to make sure that what's actually written on the label, it's actually happening. And the other aspect is that some industries really need proof that nobody tampered with the code. That's gambling, for instance, and probably some parts of the health as well. And what can we use now? What can you use in this particular point of time to add to our toolbox to make sure that everything that we want to find out about the tools, the libraries that we use, it's happening. The generators for S-bombs appeared for Kubernetes. They appeared for different type of formats. Microsoft built one as well. The Pink Owl is a tool built by Anchor called Sift. On the other hand, it's its brother Gripe that actually scans and builds the S-bomb as well. And there are other ones as well, for instance, Guac. Guac is a tool built by Google that provides all this kind of information in a more friendly way and tries to aggregate everything. But obviously, we need to look even before we build those things, we need to think about it and see how the S-bomb is. You can see a picture of a S-bomb that I took earlier. It has a couple of hundreds of lines. You can do it, take it line by line. Probably you'll not need the Netflix for the next couple of...
boring really quickly.
Yeah? Yeah. And then the other one is Bomb Doctor.
Yeah.
Bomb Doctor creates that in a visual manner. And that's...
So Bomb Doctor is an experimental tool that Sonatype's doing, because obviously we're in this space. So you can see this directly, or you can go to Maven Central, and most of the downloads that you can get will have a Bomb Doctor thing. It gives you a view of the dependencies that's come to the S-bomb. So bear in mind, that's what we're talking about. We're moving away from trying to figure out with the microscope what's in this thing to looking at a list that was produced when it was built. That's the S-bomb. And so now we can have absolute certainty we know what's in that thing, and therefore we can visualize it and connect to all the data out there. So you're going to see more of these tools come out. The point is, probably for the first time now, you can go look at your dependencies in this manner, see how your dependencies relate, and actually see how well they stack up in terms of vulnerabilities and things like that.
And before we wrap up with this part, let's zoom in on the SIG store. On the left-hand side is the SIG store. So you just have to think about it like a certification authority, the one that you think about it when you have HTTPS. So this one will be the one that will you can just go and verify that the piece of software that you have, the SBOM, is actually what it says it is. It will be a notary where you just go. It's already appearing, but it's still under development. On the other side is a community that was started around 10 years ago, I think, reproducible builds. It came from the Linux side, and what they are doing is they provide you the ability of checking if the build that you have is, you can reproduce it on your machine, on any machine, because actually that's what we tend to say, right? It works on my machine, and that's what they want to say.
Yeah.
So go see what they have to say. They have really nice resources. Unfortunately, not that many visual, but it's really nice to look into that space. So the second lesson that we have to bear in mind at this particular point of time, it's about transparency, automation, and accountability. And some guys really want to have us accountable for what we build, and they are just looking also into having legal liability for these aspects.
So it's just worth pointing that. So if it goes past very quick, we talked about generating SBOMs instead of scanning, but it's more than that. They get connected, and then they get signed. So they become proof, they become an evidence. And what you'll see from the big sticks, the governments that are turning up, they want to see evidence. So that's why SBOM is the thing in your future, as well as all the automation, because of this idea of being able to have a chain of evidence of your supply.
And because summer just got started, let me cool it a little bit and ask you if you remember what you did in December, more particularly on the 9th of December 2021. Anybody of you knows what happened then? Raise of hands, anything? Okay, I can tell you about my day. It started around 4 o'clock in the morning, and I started from the worst possible thing to start from, like a developer. I started from a Jira, and I saw a ticket that said, there might be a problem in the Java space, a vulnerability that makes waves. And this is the one. And luckily enough, I know where it all started. It's not about finger pointing, but I know who started that.
Yes, it's my fault. So, the person I was working with, security researcher, was always publishing all these really wonderful, really horrible Node and Python vulnerabilities. And I'm going, look, can you give me a Java one? And the next day he went, hey, have I got a Java one for you? The worst vulnerability in the world ever that we know of. What comes next? Oh, yeah. So we went through that really fast. But I want you just to double check that you get the SBOMs are about inverting the way that we understand what's in the software you deliver and what you depend on. And the idea of it being linked together to provide proof. And we talked about automation and stuff like that because it's important, because of that exploit first thing. So you have to have highly automated systems because you have no time to fix these things. And the transparency piece comes because the governments are not going to let you get away with this. So a big scary thing for you to understand is there are governments, EU particularly, is talking about making it a criminal liability if your company makes available software that has known vulnerabilities. Somebody in your company could eventually end up going to jail because you ship software. And the analogy that they use, and you'll hear this a lot, is the idea of if you're a car manufacturer and you shipped a car and the airbags didn't work and you knew, you would be criminal liable. And they want to apply that to software. That's what's coming our way. People are trying to fight it to make it as palatable as we can get to, because nobody wants to stop us producing software. They just want us to deal with these problems. Right. And if you don't think that's you, right, if you think this is not my problem, right, well, we've just talked about it, this thing, Log4j. So Maven Central we have access to all the downloads. And this is a reasonably current dashboard of the downloads of Log4j. The big number, let's make it bigger, which is this one, that says 33% of the vulnerabilities that are downloaded in the last 24 hours, and this number goes up and down, but it's about the same, are for vulnerable versions of Log4j. Log4Shell was sort of the straw that broke everything, because lots of governments had been talking about the fact that we should be able to self-regulate, but this virus and our ability to not fix it, these sorts of numbers, says, hey, you guys aren't paying attention. And that's what has to change. So this is about now the third bit. So the first bit was realizing that there is a big challenge out there. The second bit is understanding about the supply chains, about automation, about fixing things. And then this third one, or the second one was also about S-bombs, of course, but this one is about your piece. What can you do? What do you need to know? So the first thing to get your head around is that almost always there is a fix for the vulnerability that has been reported. The Log4Shell fix was there. Some companies who had their act together and then they had an automated system and they could apply fixes and test it and all that sort of stuff were done in hours and minutes. Large companies which had invested in the right automation and the right systems patched really fast. They were done. And if you go back at the data, you can see, right? And 60% of the world eventually got this right. But the point is, there was always a fix there. Almost always there's a fix.
And what's worth being mentioned is the fact that there were those of the companies that are using firewalls that are very expensive, and it didn't count because their supply chain was still broken and it went right through.
Yeah, well, Log4j being what it was, firewalls weren't a defense anyway. But yeah, so there's always a fix. It's just how quickly can you get it applied. But more than that, you may not have picked the right one in the first place. How often when you pick software do you pick it for the feature? Well, pretty much always. I want something to do something. I Google for it. I find an open source project for it. I might look at the license maybe, but mostly I'm going, yeah, this seems to do what I want. Maybe you kick the tires on it and then you're done. But it turns out it's a lot more complicated than that, because you're quite likely to pick the latest. But it may be that that's the wrong thing. Maybe you should pick one that wasn't the latest, right? Maybe you should pay more attention. Well, it's been hard to pay more attention because the data wasn't there. But if we could help you pay more attention, when you chose something the first time, you might not choose it in the same way you did. You may pick a different version, or you may not even pick that at all, right? So if you go to Maven Central now, you'll see there are two things. There's a link to Bomb Doctor, so I've just picked something by random, Log4j, Log4j. But you can go see information about the dependencies that you may not have realized was available to you. Obviously, you can go see which ones have got vulnerabilities in, and the Bomb Doctor will give you some other sense, right? But what we're trying to do, and these are, so if you take the Bomb Doctor, which one is this? So the left one is the OS's index, so that's where all the vulnerability information is. So you can see it tells you enough about what's going on. And the other two are about Bomb Doctor, and what we're trying to do is give you the information to make the right choice at the start. And then when you do upgrade, because sometimes it's really hard to work out how to upgrade to a point where you've got less vulnerabilities. You may be, well, if I upgrade this from version 2 to version 3, that vulnerability goes away, but that brings in a big one. So Bomb Doctor, and it's not just us, other people looking at this, is how can we give you the data that you need to make the best choices? Because if you chose the best one at the beginning, it's easier and more effective for you over in general because you've made the right choice and you're not panicking at the end. But it's complicated. So what we're trying to figure out, because I'm asking you to change what you do, is how do we give you the data you need? Well, we need you to start doing these things already, right? We want you to look at the detail, like, does it have an S-bomb? That's the first thing to start looking for, okay? Do they talk about their vulnerability process? Do they talk about their ability to update things? What's their security posture? Because if you choose something and it's not very good from a security point of view, it may not have a vulnerability today, but you can bet it'll have one tomorrow. Because if it hasn't got a good security policy, if it's not looking after its build systems, it's a nice juicy target for the bad guys. So you have to be more suspicious when you choose these things, right? Now I can give you all sorts of things to look at. What tools do they use? How many committers have they got? It makes a difference. Is it one committer or 1,000 committers? Different patterns, different choices, you know? Do they keep breaking builds, right? Do they keep leaving you with versions with no fixes? Like there's a vulnerability in this, and it's a major vulnerability, and it's been there for a year. That's not a good sign, right? Do they have unexpected releases? That's it. They release things, they release once a month. That's good, that shows they're in control. Oh no, they're released randomly. Maybe they're not the good partner for you. So those sorts of things, right? And there are others. I can give you, there's loads of stuff that we can go talk to. But at the end of the day, the thing you have to learn is to turn on your suspicious mind and start looking at the open source project for the thing that you want to use. And you can go to Maven Central, and if we know the link to the project, well, it'll be there. You can go find it. So you can use ours. There's a whole bunch of guidelines coming up. We're working with Linux Foundation and others to generalize this and put it onto the system. So you can go to Maven Central, and we're going to try and score it for you and give you this information as we can so that you make the right decisions up front, right? And we're looking at their behavior. So we're actually looking at all the GitHub projects we can, and there's a whole bunch of studies, not just us, looking at all these things. Guess what? The number one good sign of an open source project knowing what they're doing is that they do code reviews, right? And you'd be surprised how many projects don't do code reviews, right? So, and if you think about it, it makes perfect sense. Because if you ask somebody to look at your code, it means you care. Or you have somebody to talk to. Right. So these things we're trying to distill. We're doing it, Linux Foundation are doing it, CNCF, OpenSSF, OWASP, you name it. We're trying to distill down what makes a good open source project. Now, it's not going to be completely scientific, it never is. It's based on heuristic data. It's based on ideas of what makes good software engineering, but we're trying to distill it to give you some sense that this is maybe a good one, maybe this is not a good one, for you to make those right choices, right? Because it turns out that if you start to do this and make the right choices from a security point of view, and you make the right choices in terms of automation, the two together actually make you more productive. So this wonderful chart is the result of a whole bunch of analysis done by some researchers about people's attitudes and benefits towards those that care about security. Number one, all we're going to do is do security. Productivity can suffer. Those that look at productivity overall things, and those that try to combine both. And those that combine both, that looked at having automated systems that could automatically patch and that were making the right choices, were security conscious at the beginning, they turned out to be the highest performers. They got more shit done than everybody else, which is actually a really nice outcome. So there we go. the last one. So what have we got left to say? Hopefully you understand where we are. Right? This bad stuff is happening and it is not going to go away. And you are on the front line. Whether you like it or not, your behavior, what you do when you go back, how you think about this, whether you put the pillow over your head and go, no, it's somebody else's problem, or whether you look harder at how you work, it's going to make a difference. The secure supply chain security, the software supply chain security piece, you're going to have to do this. Your business will be doing this at some point, later or sooner, depending on where you are and who you provide to. If you're providing to the US government, believe me, it's going to be soon. Right? But more than anything, the last one, we'd like you to leave here knowing there are other things for you to go learn. You're at a conference. There are other people to talk to. Go look at the stuff out there. Go make different choices about the talks that you go to, right? And think about how you do software engineering and whether your software engineering is as good as it should be. And then think hard about how you choose software and whether you can make that better to get less vulnerabilities in and also improve your productivity. Done, I think.
Right about time.
Right, okay, thank you. Well, that's it. We're here all week, wandering around. If you have any more questions, then obviously come and see us. Otherwise, thank you very much for your time.